So now let's talk about try except statements. So one of the problems you run into in the Python world, I don't know if it's a good thing or a bad thing, but basically whenever Python runs into an error, whenever Python runs into something it doesn't know what the hell to do with, basically it just fails out your script, right? It's trucking along, doing whatever it's doing, runs into a problem, and boop, you are back to the command line. The script is done. So that can be a major problem, especially if you want a script running on the background, trying to accomplish something. Essentially, one of the questions you have to ask yourself is what happens if something fails, right? It goes to make an API call. It goes to communicate with the operating system. It goes to communicate with a database. And for some reason, for that one moment in time, there's a glitch. It doesn't work properly. You don't want your script just dropping out and dropping you back to the command line, especially if you don't know that's happened. So that's where try except statements come in. And basically what a try except statement does is it says try to do X. Try to write or read from a file. Try to communicate with a REST API. Try to send a command to the operating system. Try to connect to a database, whatever else. Try to do whatever it is that you want done. And then basically it says with the except, if that does not happen, what else should happen? It's almost like an if else, only for like an action statement. Like try to do this thing. If for some reason that doesn't work, what should happen? Many times you'll just say like pass or whatever, just skip that and try it again later, that type of deal. But that's basically what a try except statement does, is it tries to take an action. If that action fails for some reason, it gives you a fallback for Python to be able to do something so that there's not an error. Python knows what to do when there's an issue. Now the try except statement is going to seem a little confusing to you for the first, maybe a few minutes that you're using it, but once you get used to the terminology, it gets to be relatively easy. So essentially in the try except statement, the first thing you're going to do is try. Try to run this block of code, whatever it is. Then you have the except. If that block of code is not able to execute, what different thing should occur? Should you write to a log file? Should you put something up on the screen? Should you just pass and wait for the next time to see if something happens? That type of deal. Then you're going to have an else. So what the else is if the try works. So the try works. You were able to connect to the REST API and do something. If that has worked, what else along with the try do you want to accomplish, right? And that's going to be what the else is for. It's not something other, it's that try worked. And so since try worked, we are also going to do these other things. And then you have finally, and basically what finally is whether try worked or whether it went to accept. Basically finally is at the end of the statement. It is the final thing to do when everything else has been done. So now let's look at an example of a try except statement. So we're going to be using a while true like we do for some of our labs, so you can keep inputting information and seeing what the different responses are going to be. So we have try. So try colon. And so what's going to happen here is number one is going to equal an input. So enter the numerator. What we're going to be doing here is we're going to be dividing two numbers, right? Dividing the top number by the bottom number and seeing what the response is. So input, enter the numerator. That's the top number. And we are going to put that within the int function to turn this into an int, right? A whole number. Num2, again, enter denominator. Basically going through the int function to turn that into a number. And that is going to be num2. Result equals num1 divided by num2. Print the result is whatever the result. So basically what we're going to try to do is we're going to try to get the input as a number, the second input as a number. We're going to try to divide those, and we're going to try to print that out onto the screen. Except if there's an error here, for whatever reason, if there's an error here, we can do accept exception, so this is basically the error, as E. So we're giving exception an alias of E, and then we're going to print out error colon whatever this value is. So basically with this except statement, what we're just simply saying is if this doesn't work, we just want an error printed out on the screen, what was the error, right? Then we have else, right? So try. So if this works, the else, the and, is print the user inputted numbers, right? I don't know, for some reason, somebody might try to input Bob, right? So that wouldn't work out. So we're just going to print out on the screen, yay, the user did what the hell they're supposed to do. And then finally, so finally is when everything is done, print execution of the try except block is complete. So whether this worked or whether there's an exception, this will run regardless. So then when we go to run this, right? So we hit run, end of the numerator, the top is 8, the denominator, the bottom is 7. So we get the result is, right? So if we looked up here, right, the result is, so this is within the try statement, we get the result is, that's the number. The user inputted numbers because it worked, so that's the else. And then we get to the end, execution of the try except block is complete because that is at the end, right? So basically the person put in all of the numbers like they should, and so we got everything out how we should. Now let's say we go and we run this script again. So we say we enter the numerator, 9, and we enter the denominator, Bob, because it's always Bob at the end of the day. We hit enter, right? Then we get the failure, right? We have this exception E, right? So exception as E, so this is the error. So we're going to print out the error, and that's what we have here. So the numerator was 9, the denominator was Bob, right? Error, invalid literal for int with base 10 Bob. So basically saying Bob isn't a base 10 number, so that's what your error is. We still have the finally, because even though it errored out, right, we're coming to the end of the overall try except block, so execution, and so we still get that execution of the try except block is complete because that is what we get at the end. So this is basically all there is to try except statements, is you're going to try to do something. And again, it might be a number, it might be getting input from the user, validating that input. Again, communicating with the REST API, communicating with the OS, that type of thing. We're going to try it. If that doesn't work, we can do an except, what to do if this doesn't work. The else is what else to do if try works. And then finally, after all the other code is done, what is the final thing that should be done? Now with that exception as E, right, that is basically the error code. What was the error? So there are a number of different built-in exceptions in the Python world if you want to try to test for the different reasons why a try except a statement might fail. You can have a syntax error, a type error, a value error, index error, key error, name error, zero division error, attribute error, and a whole bunch of other errors. So again, depending on what you're trying to do with your try except statement, you might want to go through to look at these very specific errors to figure out which one is most relevant for what you're trying to do. So here I have a bit of a modification of the example I just showed you, where instead of just using the exception as E, we're actually going to have except statements for different types of error. So since we're trying to divide two numbers, again, for whatever reason, there actually is a standard zero division error. You can't divide a number by 0. I don't know, for some reason that's actually built into Python. So that's an error that exists. Or we have a value error. So basically, if the value that is supposed to be coming in doesn't work out right, again, if I put in Bob instead of 1, 2, 3, 4, 5, then we can get this for the value error. So again, we go and we run this, and as we did before, we do 9 divided by 8, and we get that. So that's no big deal, right? Let's try this again. We'll do 9 divided by 0, right? Now we get this error, cannot divide by 0. A number divided by 0 doesn't work out. So, right, so we're getting a special error based off of that very specific issue that we're having. If we go through this again, and let's say we do 8, and this time we try to divide 8 by Sue, and here we get the error, please enter a valid number, right? Because that is a value error there. And so that's one of the things you can do too, is you can have these excepts based off of the specific type of error that is occurring, so that depending on what it is that occurs, you can have different things fire off. So that's all there is to try except statements. It's a very useful thing in the Python world because, again, if you make Python unhappy, the script just stops and then all kinds of hell can break loose. I will tell you, many times with Silicon Dojo, again, based off of our bias, I'm trying to teach you very specific things. Many times we skip over try except statements when we're doing things because I'm trying to focus on teaching you a concept. Like I'm trying to focus on teaching you a REST API call or interacting with the operating system or anything like that. When you are building your own labs, when you are playing around with your own code and you're pretty sure everything is stable, everything should work, and if it doesn't, you can just hit run again, right? You don't necessarily need these try except statements. Again, when I teach you about REST API calls, we're more or less going to skip this just because this adds more text to what I'm trying to show you, adds a little bit more confusion. Again, we're dealing with the operating system, the same thing. What I want you to realize though is when you start actually making anything that will go into production, right? Any Python project that's basically fire and more or less forget, you're going to turn it on, you're going to walk away, and you want that thing to keep working in the background. At that point, anything that might fail, you need to wrap within that try except statement again. And that's anything from writing to files. So if I'm going to be writing or reading from a file, what happens if that file isn't there or it's not accessible? And this particular iteration when the script is going through, again, with the REST API, the OS module, something like that, what happens? Again, if this thing is just doing a continuous loop, it's just supposed to be doing a continuous loop 24 hours a day, 7 days a week, 365 days a year, what happens if just at one point there's just a small glitch? There's just a blip, right? A blip. And for some reason, the thing that your script can't connect, can't do what it's supposed to do, right? At that point, is your entire script going to fail, or is it just going to go to the except part of the statement, do a log file or whatever else, and keep going on? That's why the try except statements are so important. And so that's why you'll see, like with a lot of our classes, when I'm teaching you things, we won't use the try except statements. When we start going more into labs and when you're actually trying to build something, we'll start using those try except statements a little bit more just to give you the feel of how it's supposed to be. But anyways, that's what they are, and that's why they're important.